Hi guys, and this is the first Chem Talk, and joining you today is David B. That's me. Today we're going to be talking about one of the most fascinating elements known to humans, the element that we always wonder about. Radium. I know, random, right? When we think of radium, we might immediately have a thought in our head of superpowers. No, radium with the bite of a spider does not make you climb on walls and be 10 times stronger. However, it has some fascinating uses along with its physical and chemical changes. Now you may ask, why did I do radium? The answer is, just because. It is a free country. I have brought pictures for this special occasion because radium is highly dangerous and you want to see me talking throughout the whole video, right? So let's get going. Radium is the 88th element of the periodic table and has the atomic mass of 226.0254, which is a relatively high atomic mass. This means that it has 88 electrons, 88 protons, and 138 neutrons. It is located at the bottom of the alkali earth metals, or the second group of the periodic table. So this is radium. As you can see, it has 88 as its atomic number. And this is the amount of electrons it has. 88. Same amount as the protons. 138 neutrons in the nucleus. Pretty amazing, right? And if you can see this, right here, this is where it's located. So, radium was first discovered by the world-renowned scientists Pierre and Marie Curie in 1898, along with other elements they discovered, such as francium and polonium. They ended up winning the Nobel Prize because of these discoveries. They first discovered radium bromide in pitchblende, which is basically uranium dioxide, which we can say was 1 uranium atom and 2 oxygen atoms. However, only 1 gram of radium can be produced for every 8 tons of pitchblende. Metallic radium was discovered in 1910 by the electrolysis of a solution of pure radium chloride. Electrolysis is basically separating the atoms from a compound using electricity. Marie and Pierre's early deaths were the cause of the radium's radiation, along with other elements hazard in which they studied. So, this is a picture of them. This is a picture of pitchblende, in fact. And, yeah. So, most people imagine radium as light green. However, pure radium is a grayish-white color. It has luster, but it might be difficult to see from all its glow in the dark effect. Radium is also solid and its radioactive remains or decay product may form radon, which is a noble gas. It has a melting point of 700 degrees Celsius and a boiling point of 1,500 degrees Celsius, which is hotter than the surface temperature of the sun, and definitely hotter than this fireplace right here. Its density is 5.5 grams per cubic centimeters. Radium has 33 isotopes, which means that there are types of radium moles, but with different amounts of atomic mass. These range from radium atoms with the atomic mass of 202 to radium with the atomic mass of 234. But the most common one and the longest existing is radium with 226 as its atomic mass. Its crystal shape is body-centered cubic, which means that its crystal structure is based off cubes with a central point in each reaching the vertices with beams. Radium is obviously opaque because we can't see through it, and because pure radium is so fluorescent. This takes us into our chemical properties. So, this is body-centered cubic. This is its crystal shape and how it would look like. And this is radium, pure radium, in fact, pure metallic radium in the dark. As you can see, it is glowing and it has that glow in the dark effect. It is true, radium is radioactive. You won't die immediately if you touch it, but long exposure can cause harm. Radium's mixture with the air makes it turn from pure grayish white to have a black coating because of the nitrogen. Radium's glow-in-the-dark effect is probably why people believe it is a light green. However, that is because of its radioactivity. Radium is the most volatile out of all the earth metals, and it reacts strongly with water, decomposing and forming radium hydroxide. Radium is also highly reactive with hydrochloric acid, releasing the hydrogen to form radium chloride. Apparently, the heat given off from radium is 0.12 joules. When one puts radium to a flame, the flame turns into this color, which is crimson red. Now, these are the elements it is highly reactive with. Just a little recap. So, nitrogen is a compound, by the way, not an element. Water, H2O, and hydrogen chloride. However, where can one find this magnificent element? Sorry for that. Well, radium is actually in every uranium product and can be extracted from each. Therefore, we must look towards the uranium mines, such as the one in Zaire, Utah, New Mexico, Colorado, and even Ontario in the Great Lakes region. Yes, we can find radium and uranium and in the great country of Canada. For all you Americans out there, don't worry, your cousins won't die, since I have not died yet, and I live in Canada. After uranium is mined, people use electrolysis to get the radium, or they capture all the degrading uranium. This is a map of uranium mines in Canada, and big one is right here in Ontario, and I live around here. And what's the point of mining radium? What is it used for? Radium nowadays is used for some cancer research. However, it was mostly used in the 18 to 1900s. Those fluorescent clocks, that was radium. When they turned it into radon gas, they would use it for cancer research because its radiation would stop cancer cells from spreading, which is an interesting fact. However, it was also dangerous, and too many amounts could cause serious problems. The use of radium ranged from cosmetics products to toys to toothpaste, and even in food. Yes, there was some chocolate that had radium. That's crazy. Some people were really desperate with comics back then. However, this would all stop once they realized how dangerous it was. So, they had radium clocks, such as this, and they would help out with cancer research. So, did I mention radium was radioactive? No. It's crazy radioactive. And I'm not talking about the song by Imagine Dragons, Radioactive. I mean radioactive that makes people die. Radium's radioactivity had side effects such as skin burning, neurasthenia, anemia, and feeling weak, and surprisingly, too much exposure may cause some forms of cancer. Radium can be a threat to the environment, especially in water streams and even the air. Radium in water streams is very dangerous because it can also biomagnify the health issues along with harming various animals by the stream. Also, mining in the uranium ores can cause serious pollution. And yes, it is radioactive. Very, very radioactive. One of the most radioactive elements in the periodic table. So, be careful with that. So, these are some interesting facts. Radiation can still be found on Marie Curie's notebook. It takes radium 1,602 years to have half of its radiation. Radium's name originated from the Latin word radius, which means ray. Only 5 grams. 5 grams of radium are produced each year, and it costs $100,000 to $120,000. 1 gram of radium with 226 at its atomic mass decays at the rate of 37 trillion disintegrations per second. It resembles barium in chemical behavior, but it is more radioactive. Compounds radium formed are with almost all the halogens apart from nitrogen and oxygen. Now it's time for our chemical question of the day. This one was sent from a kid named Billy. So he's asking, do glow sticks have radium in them? No, of course not. Do you really want your parents suing the company? The light produced from the glow sticks is actually coming from chemical luminance, something you, Billy, may be learning in high school. If radium was in glow sticks, then it would be a complete waste of resources, and parties would not be so popular anymore. Radium was not an important discovery, but a very interesting one. The element intrigued people and based some sci-fi off of it. I hope you guys enjoyed this video, and I'll see you next time on another Chem Talk. For all you rich people out there, big, suggestion. If you like radium, please, I know it's the holiday season, but don't hang it on your Christmas tree. Please. I'll see y'all later.